Okay, in this video we're going to talk about iSCSI. Okay, it's an overview of iSCSI. So up until this point in the labs, you have shared files from the SAN to the Linux and Windows hosts using CIFS or SMB and NFS. And those are great protocols for sharing folders from one workstation to another. But this is something you could do already with a Linux host. You can install the NFS service on the Linux host and share folders like that to your systems on the network. Or from a Windows server, you can share a folder and share it through CIFS to any other host on the network. And those are great, those work great. But the difference in SCSI is that you actually are getting a block device. And what is a block device? A block device would be what a drive is on a computer, okay? So typically when you install a hard drive on a computer, you buy the hard drive and you connect it to the motherboard of the computer, right? And that's how you do it with a conventional hard drive. Well, think of SCSI as the same thing, but instead of having that wire from the hard drive to the motherboard, TCP/IP takes care of that connectivity, okay? So that's how iSCSI works. But essentially, when you do it and you connect from an iSCSI server, which is called the target, to the initiator, which is the client, the computer that's getting the disk, the client is going to get a disk, and it's going to act and feel just like it would if you would connect the drive to that computer. So let's take a look at it. So for the lab, basically so far what we've done is we've created a volume group called iSCSI, and inside that volume group we've created 4 individual volumes, okay? And these volumes are 192 megabytes, okay? So I've already done that. You already know how to do that, and that's great. So now what we're gonna do is basically take these 2 volumes, LV0 and LV1, and present those 2 disks or volumes to the Linux client, the Linux computer. And we're going to take the LV2 and LV3 volumes and present them to the Windows machine, okay? And I'm going to show you how to do that. This is a very important lab because it's the very first use of the SAN capabilities in this course, okay? So nowadays you can do this via iSCSI, which is what I'm going to show you how to do, or you could do it via fiber channel, which is another way of communication between the SAN and the host on the network in order for the SAN to present disks to the host, okay? So I'm going to show you how to do it with iSCSI. Okay, so the first thing we're going to do is, now that we have created our volumes, I'm going to go to Services, and we need to enable the iSCSI services, okay? So this is an open filer SAN. We need to make it an iSCSI server. In order to make it an iSCSI server, I gotta make sure that iSCSI target server is enabled. And in my case, it's enabled, so I'm good to go here. iSCSI target server is enabled, so I'm ready to present these disks to other hosts on the network. Okay, so to do so, I'm gonna go to Volumes, and I'm going to click iSCSI targets, okay? And then iSCSI targets, I'm going to click target configuration tab, okay? So the way OpenFiler works is you basically create targets under the target configuration, and think of a target as a way to represent an instance of the SAN to a host. So typically you would create 1 target per host. Okay, so in our case we're going to create 1 target or 1 connection to the iSCSI server for the Linux machine, and then 1 target or connection from the Linux server to the Windows machine. Okay, so what you do is you go to the target configuration and you create, first we're going to create these 2 targets here. And these targets are represented by these things called IQN. IQN stands for iSCSI qualified name, and it's basically a name that you give to the server pieces and a name that you give to the client side pieces, the initiator, okay? So both the target and the initiator will have IQNs. Now in the target IQN, like I said, we're going to create 2 targets, one for the Windows host and one for the Linux host. So here in the lab it tells you to remember the IQN that you're going to select for the Windows, and remember the IQN that you're going to select for Linux. So what I'm going to do is this IQN could be anything. It could just be X, it could be XY, it could be foo, it could be bar, it could be whatever you want it to be. So what I'm going to do is I'm going to remove this last piece after the last colon, and I'm going to put here Linux in capitals, and I'm going to add it. Okay, I know this is not what the lab says to do. The lab says just to take what's in there, but I think that if we use it this way, then it's easier to know which IQN is for Linux and which one's for Windows. So I'm going to do the same thing for the second one. I'm going to remove everything after the colon, and I'm going to put Windows, and then click Add. Okay, but like I said, you can name these things whatever you want them to be. Okay, it really doesn't matter as long as they're all different. So here, in order to configure these things, you have to select, now that I've created both of them, I have to select one. So I'm going to select the Linux one first and click Change. So it's the selected one. Once you selected Linux, then you can go to a LUN mapping for the Linux one. Okay, so now I've selected the Linux one, and I'm going to go into the LUN mapping. Okay, so let's talk about LUN mapping. What LUN mapping does is it basically maps a volume that you've created to a target. Okay, so we said we wanted these two volumes, LV0 and LV1, to map to the Linux host, and then we said we wanted the LV2 and the LV3 volumes to map to the Windows host. So that's what we're going to do here. Okay, so the lab says that the first one's transfer mode, the LV0 is going to be block I/O, and then the second one is going to be file I/O. Okay, basically the difference in these transfer modes is the way caching is used on the target. Okay, so you're not going to notice too much of a difference, but I've heard that block I/O seems to perform a little better than file I/O. So once again, the important thing is that you take a volume here and you map it to your Linux target. So we're going to map these two. So we're going to click Map on that one, and then Map on the second one. So now LV0 and LV1, whoops, so I forgot to do this one, file I/O. So I'm going to unmap it and come back to it and change it to file I/O, because that's what the lab wants. Okay, so now I got it right. I got block I/O and file I/O, and I got the first and second LUN IDs. Okay, so now that I've done that, I need to go to the next tab, which is the network ACL. So basically here what this does is it's going to allow access to any host on this network. So there's going to be 192.168.1.1 to 192.168.1.254. Any IP address on that net mask is going to be allow access to this target, which now contains two volumes. Okay, that's the way you need to think about it. So the danger here is that since both my Linux and Windows clients are both on the same network, they're both are going to see both each other's targets. Okay, so we need to be careful when we configure the initiators on the Linux and the Windows side to make sure that they only look at their particular target, not all the targets, because if we don't specify a particular target, then they're going to see each other targets, and they might overwrite, they might corrupt the file system. Because what happens is when you share these disks on the network, if you have two systems that try to mount the same disk, they are going to corrupt the file system. The only way that would work is in a cluster environment, if you had a cluster file system. Okay, if you have a cluster file system, then you could have multiple hosts on the network that connect to the same SAN volume, and that's allowed because the cluster file system basically takes care of making sure that the file system stays consistent. So Oracle, for example, has a cluster file system called OCFS that you can use for this type of thing, and Red Hat has one in Linux as well, and you could do it that way. But in our case, in our environment, our Linux server is going to be an extended 4 file system type, and Windows is going to be NTFS, and neither is a cluster file system, so we don't want both hosts to see the volumes of the other hosts. Otherwise, we're going to get corrupted file systems. So we have to be careful. So we're not going to do CHAP authentication. This is something we're going to do at a later time. So right now, our only way to secure these things is to allow them only to this network, 192.168.1.0. So now we're going to go back to target configuration. This time we're going to select the Windows target and click Change to select it.